Good morning, everyone. I've still had a couple of questions on the rough draft, but I really wanted to address the second half of the project as well, because I know that there will be questions there as well, so I just wanted to head those off and kind of talk about regression as well, since we're going to have to do that for the discussion board this week, so I might as well kill two birds with one stone. So as you know, you're going to find your data set, which you have hopefully done your scatter plot. I'm just going to talk about SATs just for fun. I'm not going to actually plot it. I'll plot a little data set just to give an example. But the first paragraph I just want to talk about real quickly. I know a lot of you did a great job talking about how you love movies or how you love food, or everyone of course loved the SAT testing scores. But the real thing I wanted to see is, what are the benefits of analyzing this data? Can we predict test scores? Can we predict batting averages? Can we predict how many carbs are going to be in something with a certain number of calories? Honestly, that's going to vary, right? If there's high protein, that's not going to correlate as well as if it's high carb. But we can do a decent job usually. We can't always do a perfect job, but we can do a decent job. So talk about the benefits of analyzing this data. So the data I'm going to analyze is the age of a car versus price. So I can talk about how I love cars, but then really what I want to talk about is how I need to sell a car or buy a car, and I want to predict the cost of a car in 10 years or 5 years or whatever. Most people don't keep cars 10 years anymore these days, so we could say we want to predict the value of the car. Value is probably better than cost of a car in 5 years. So how can we use this data? What is actually important? So that's step one. Step two, you're going to create your scatter plot. Something that I've still seen a lot of is if I plot this scatter plot, which I have done, and where's my buttons? There are my buttons. Okay. I'm getting a lot of graphs like this. Does this graph give you very much information? It doesn't. So look at these numbers. Where are my numbers? All of my numbers are between 0 and 11, or 4 and 11. So I really want to zoom in here quite a bit. Now there is a difficulty in that these go up a little higher. Now I did change these. These are in hundreds. So this is $6,300, $5,800, but I didn't want to go way up high. So you can actually, if I wanted to, I could just go into my settings and I could adjust this. I could be like, you know what? I really only want to go out to 11 here, or 12. Let's say I want to go to 12. And on my y-axis, I don't need any negative numbers. So I'm going to go from 0, but if I like seeing the axis, sometimes I like a -1 just to give me a little bit more. And then let's say what's my highest number, 63, so I can go to 100. I want to be able to, and you can just play with the zoom and move it around, but I want to be able to actually see my data. The whole point here is to be able to see what is happening with the data. And so we're going to screenshot it, put it in there. Tell me how you chose the axis. Do we need negative values? Do we need really high values? Tell me what they mean. Tell me, is this linear? This is linear-ish. I mean, it's pretty decent. If you look at, I have a couple of examples here. If you look at some of these examples, this is very linear. Whereas this one would be more linear-ish. And you can look up the technical term. It's all in your notes. But the idea is that it still is linear. But if you're looking at something like this, that would not be linear at all. They're all over the place. And even if you look at something like this, this is actually not linear. It goes up and then back down. I don't know any lines that go up and back down. So this would be a different type of function when you get onto college algebra, then you can play with those functions. But that's the idea here. When it asks, is this describe the strength of the linear relationship, or what kind of a linear relationship? Is it positive? Is it negative? Does it go up or does it go down? So like this one goes down. This would be a negative linear relationship. Whereas this one would be a positive because it's going up. You pretty much base it on the value of the slope. And then the strength of it you can determine based on what it looks like. You can hypothesize about the variables in the data set. Tell us what they mean. Do you feel like this would be a good predictor of the future? You know, this one, man, if you did a linear model here, this should be a great predictor of the future. Whereas if you're doing one over here, definitely not a good predictor of the future. And then you're going to calculate by hand. Just choose 2 points. Yes, you're going to get a different answer if I choose these 2 points or if I choose these 2 points. It doesn't matter which 2 points I choose, you're going to get a different answer, and then I want you to plot it on the same thing. So if I were to choose, well, that would be 0. I don't want 0. That wouldn't be a very nice graph at all. So if I choose these two, we're looking at -6. Plus, I'm not really doing, I'm just going to guess here because I don't want to actually do it by hand. But you're not going to guess, of course. You're going to do it by hand and show me all the work. And so that's a decent graph there. That gets me kind of close to them. And so you're going to talk about it. What does this y-intercept mean? Well, when x is 0, that means when the car is brand new, that the value would be this. So what does that point mean with your data? And over here, when y is 0, that means that my car has no value anymore. So it will tell me how many years it takes before the car has no value. So that's what I mean. And what does the slope mean? That would tell me each year. So because this is in hundreds, each year the value of my car would go down by $600. Well, that would be nice, wouldn't it? Unfortunately, that's probably not super accurate. But that's what we can talk about. How accurate is that? How helpful is it? And does this fit pretty well? This fits decently, but definitely not perfectly. But that's how you would talk about the intercepts and how you would talk about the slope in terms of what it means in your model. Make sure I didn't miss anything else there. So now we're hitting into best fit lines. So you want to create a best fit line. Not the one you did by hand, so I'm actually going to go ahead. Well, actually, I'm going to leave it on here so we can compare them. So when you do a best fit line, and I have like this beautiful little, I'm going to send you a link to this that will walk you all through how to do regression in Desmos. But you're going to start with y1, and you're going to use this little tilde. And I'm not going to lie, I had to do some research on where to find the tilde. And the tilde is to the left of the 1, and it looks like I have to use shift to get it. So you want to use this little tilde symbol, and then you're just creating a generic equation. And I didn't have to do anything fancy to get those subscripts. I just did y1, shift my little tilde, left of the 1, m x1 plus b. It fixed it all for me. Desmos is so user-friendly. It makes me so very incredibly happy. So we can now look and we can compare. So it says the slope is -5, which is -573, compared to my -600. They were actually pretty decently close. And the y-intercept is actually, wow, I did a pretty decent job doing this by hand. But I can compare, but theirs is obviously better. So my slope was a little too extreme, a little too steep, and they unevened it out. And if you look up the R values, this is actually a really good R value. So according to the R value, this is a great linear relationship. Now, in general, if we had tons of different types of cars, it might not be so great. But if you stayed in one category, like if you just did minivans, this would probably be much more accurate than if you were comparing sports cars, minivans, compact cars. This is going to vary greatly because your initial values are going to change a lot. You're going to have an $80,000 car, but you're going to have $40,000 cars. And so this could vary more wildly. But I think the more narrow your scope is, the more decent this would be for a linear regression. So you're going to talk about how to do the best fit line. You're going to take a picture of this for me. I do want to see all of this information. You're going to identify the slope. So m is the slope. B is the y-intercept. You can also go out here. I would have to zoom out a little bit. I can find my x-intercept is at 15 years. So according to my linear regression, at 15 years, the value of a car would be 0. Accurate or not, that's what the model says. Make sure you tell me what all of that means. And how well does your calculate it? So now saying, well, compare. How good was yours compared to theirs? Mine were pretty close. Some of yours, depending on which, if I had chosen 2 different points, had I chosen these 2 points, 45 minus 45, I would have had slope 0. That wouldn't have even been kind of close. So choosing wisely will get you closer, but if you just choose randomly, they might not be as close. So compare them. See how close they are, see how close they aren't. Tell me about it. Why do you think they weren't as close? Then test 5. This is the one of grading last session that pretty much everyone just skipped. State what test values you chose that are not included in your data set. Report on the outputs to these test values. What do they tell you? Do the results seem to fit with the rest of the data points? So I want you to test. So don't choose a data point. I want you to choose, let's say none of these are x equals 2. So I'm going to take x equals 2, and I'm going to go to this equation, and I'm going to plug it in. I'm going to find the point. And I'm going to go to this equation, I'm going to plug it in and find the point. And see how close it is. Does it fit? Does it look right? Or you can choose one that already exists. You could choose x equals 7 and plug it in up here and plug it in down there and see how close it is. You know, to your data set. Is your data set close? How close is it to the graph? So you could look at this point right here, and it's fairly close to the line. Like, none of these are on the line. None of these are on either line, just so we're clear. So choose one data set, and you can plug it in and see how close it is. So actually use one of the ones on here. I think that will be more meaningful. So say you choose x equals 8. You can plug it into this equation, and you know you're going to get that point right there. It's going to be 37. And on the red one, it's going to be 32. So you can say that it's much closer to the linear regression than it is to mine. And if you actually compare all of them, they should all, in general, there are going to be a few outliers, like namely the points I used to help me find my line. That'll be closer to my line than they will be closer to that one. So you can compare. I want you to test values. And see how close things come or what it's going to be. So you could go in and test x equals 2 and see how different they are and what the actual value would be. Is this going to be a good predictor? I mean, I can have a 20-year-old car and it's definitely not going to have a negative value, especially not in today's market. So you want to talk about the different points and the different values, and then in your conclusion, which one do you think would be better? Which one would you choose to better fit your data? Identify any characteristics. They both have negative slope. And just talk about their behavior. Could we improve the fit of the line? Maybe narrowing our data, or, I mean, sometimes you can look and see, not in this data in particular, but you could, I mean, if you're looking at this line right here, you can say, well, this data point seems really off. And so maybe you could look and gather more data. That might help you. And then just talk about whether you think this would be a good model to use or not. You know, if you're giving a report, you need to give a conclusion, right? Is this a good model? Why is it a good model? Which one would be the best model? And that is what you're looking for. But it's this test values that often gets skipped, and then I have to take off points, and I don't like taking off points. So I would do both. Like, I'd look at these and see, oh, look how close these are. And then plug in x equals 2 and compare them and see which one you think would be more accurate. Or x equals whatever. Not, I mean, 20, obviously, they're both going to be horrible. But if you did like x equals 12, you could still get decent points here that would be interesting. And that should give you a general idea of piecing all of this together. If you still have questions, please let me know. Hopefully this was helpful, and we will be doing linear regression on the discussion board, so let's make sure we all get that down first. Now, your project is not due till next week, but please know that it is due on Thursday, and your final exam is due on Saturday, and that's a lot. So please work on getting this done sooner is my recommendation. If it were me, I'd want to have it done this week so I could focus on the final next week, but of course that's up to you, and I will just grade them when they come in. But let's have a great week. If you have questions, let me know, and thank you for all your hard work.